We're now going to look at 4a and 4b, which are quadratic functions. This is where we're going to eventually to be able to understand the general form of the quadratic function, to be able to understand the minimum and maximum values that it might have, how to be able to sketch it through finding the y-intercept and x-intercept, through finding the turning point, and of course being able to solve those equations in order to be able to sketch it as well. But what we're going to start off with is using appropriate techniques to be able to factorize the quadratics. So we're going to do a couple of these examples. First of all, it's 9a squared minus 24ab plus 16b squared. So here, what you need to be able to recognize is that this is actually the perfect square. So what that means is we're going to be using this formula: a plus b all squared is equal to a squared plus 2ab. This is a little bit hard to recognize that it actually is this form, and we can factorize it down to this. But a couple of ways that I sort of was able to look at this and say, hey, it might be this, is that both 9 and 16 are perfect squares. So I could write this first term as 3a all squared and this last term as 4b all squared, which tells me that, and I know this is a bit confusing because there's lots of a's and b's, but this a and this b is these particular terms. Now, if this is true, if this is actually the formula that we're using, that means when I multiply those two values by 2 as well, I should be able to get this middle term. So we can test it out and check if that is true. So 2ab, so 2 times this value times this value. So you'll see that 2 times 3 is 6, times 4 is 24ab, and in fact we do get this middle term. So what we have here is a form that actually is the perfect square. That means I can factorize it down to this. Now I've recognized that my first term a is 3a and that b is 4b, so then that means I can factorize this down into 3a minus 4b all squared. And the reason that I use minus is because this middle term also has a negative. So this is all about recognition. Next, we've got 6x squared minus 17x plus 7. I try to look at it, see if there's any common terms that I can take out. Can I perhaps use the perfect square? All of the answers to those are no, so what I need to do is I need to factorize these into brackets. Now, the other thing you need to recognize is that there is a value outside of x squared, which means I can't just think of two numbers that multiply to give me 7, add to give me negative 17. I have to take that initial value into account. So in this case, we're going to multiply over. So this is when we multiply a times c, so our first term and last term. And essentially, I want two numbers that will multiply to give me whatever 6 times 7 is, so 42, and two numbers that add up to the middle term, which is negative 17. So normally we just think of the last term, but when there's a term in the front, we need to multiply them, and that's how we get that value there. So two numbers that multiply to give us 42 and add to give us negative 7 will be negative 14 and negative 3. So what we now need to do is split the middle term. So once again, because there's a value in the front, we can't just write it into brackets, but we must split the middle term. From here, we can factorize by grouping. So I'll factorize those two. I can pull out a factor of 2x here. So then that will leave 3x minus 7 behind. And here I can pull out a negative 1, and then that will leave 3x minus 7. Then what you'll notice is that these are both the same term, so I can pull that out. That'll be 3x minus 7, and then what's left over is 2x minus 1. And that there is fully factorized. Next, what we're going to do in this case is that we can see that there is a common factor through all of the terms. There's a 2, so I can take that 2 out. So that'll leave t squared plus 4t minus 7 behind. And now I try to think of two numbers that will multiply to give me 7, add to give me 4. Unfortunately, there are no numbers that help me do that. So in this case, what I have to do is I have to use either the quadratic formula or I can complete the square. Both of them work. I think completing the square is slightly easier with numbers such as this. So in order to complete the square, what we want to do is add half of the middle term. So the middle term in this case is 4. We're going to add 2, square it, and then subtract 2 and square it as well. From there, these three terms make the perfect square. So I can factorize that down. That'll become t plus 2 all squared. 2 squared is 4, so that'll be negative 4 minus 7, which will be negative 11. By year 12 level, I would hope that you'd be able to go from this step directly to this step over here without having to add these middle terms. So really, it's just half of that middle term in the bracket and then square it, and then either add or subtract it to the final term. Now what you can recognize, hopefully, Just talking shit. It's okay, I'm going to cut it out. But I'd rather not have to. Okay, so at this point, we've now completed the square, and we can notice that there is a negative here, so we can see that it is the difference of two squares. So in this case, I can call this term a squared minus b squared. Of course, we can recognize that a quite easily is t plus 2, but b is not a perfect square, but if I were to try to take the square root of that, it would just end up being root 11. So now I can factorize this down into the formula a minus b, a plus b. So we've just got a 2 that's hanging out at the front, and then that will be t plus 2 plus root 11, and then t plus 2 minus root 11. And that there is fully factorized. Once we've learnt how to factorize, we can then move on to solving quadratic equations, which is quite straightforward. As long as you know how to factorize, what we can do is use the null factor law to be able to make the equation equal to 0 and solve from there. So example 7 asks us to solve this particular equation. What we can see is that there is a value outside of the x squared, which means we will have to do our a times c formula. So a times c, in this case, it'll be 6 times negative 3. I need two numbers that multiply to give me negative 18, and two numbers that will add to give me the middle term, which is negative 7. So those two values are going to be negative 9 and 2. So I'm going to split the middle term into that. So I will have 6x squared minus 9x plus 2x minus 3. And then, as I did before, I can factorize by grouping. Here I can take out 3x, so that'll be 2x minus 3, and then that just remains as it is, 2x minus 3. I can put brackets though and put a 1 in there, just so that I know to take that out later. Then these two terms are the same, so that's 2x minus 3. What's left over is 3x plus 1, and of course, this whole time, all of this is equal to 0. So from this point, what we're going to do is use the null factor law. So the null factor law is that if I have two values multiplied by each other, a times b, and it's equal to 0, well, the only way to get 0 is to have one of those values or both be 0. So that means a will have to be 0, or b has to be 0, or both. So that's where we get the null factor law from. So that's 2x minus 3 equals 0, 3x plus 1 is equal to 0, and then what we can do is solve for x. So I'm going to take the 3 over and divide by 2, and I'm going to take the 1 over and divide by 3. So my two values will be 3 on 2 and negative 1/3. A very useful tool though is to use the quadratic formula when required, especially if we have some tricky numbers. This is an example of where we can use it. So here we can't factorize it easily, the quadratic formula can come into handy. So the first thing we need to do is figure out what our values of a, b, and c are so that we can substitute in. So a will be the value in front of the x squared, in this case it's 1, b will be 8, and c will be 3. Now we've figured out those three values, we can substitute that directly into the quadratic formula. So it'll be negative b, so negative 8, plus minus b squared minus 4ac, so that's 8 squared minus 4a1, and c, which is 3, over 2 times a, so that will be 2 times 1. And from there, it's just a matter of simplification. So inside 8 squared is 64, minus 4 times 3, which is 12, that'll be 52 on 2. What we can then do is simplify that surd of root 52. That's the same as 4 times 13, and then when I take the 4 out, it will become a 2. So that's 2 root 13 on 2, and then we can see that both the 8 and 2 have a factor of 2, so I can cancel those out. That becomes 4, and then that means that x will be negative 4 plus root 13, and negative 4 minus root 13. So that's how I can use the quadratic formula in order to be able to solve for my x-intercepts or x values. Example 9 is an exam question. So it tells us let f be this function with these rules. So it's 2x squared plus 12x plus 10. Firstly, what it wants us to do is write f of x into the form of this. This is turning point form, which we can get from completing the square. Complete the square. And then part B says, hence write down the coordinates of the turning points of the graph of f. So the turning point is h and k, and we can get that from our completing the square. So it's the same in this case as b and c. So here is our equation. What we can see first of all is that there is a common factor in all of the terms, which is 2. So that's the first thing I'm going to do. I'll take that out just to make my life a little bit easier. Then in terms of completing the square, if you remember before, the quicker way to do it is you just add the middle term. In this case, that will be 3, half of the middle term. And then we will subtract that, square it, and have anything else that we need to add or subtract left over. 3 squared is 9, so negative 9 plus 5 will be negative 4. I'll then multiply that 2 back into the equation. So we'll have 2x plus 3 all squared minus 8. So that's part A done. I've now got it in turning point form, and that's going to help me find that turning point. So as we said, it's our h and k, or in this case b and c as they've labelled it. So that will be negative 3 and negative 8. Don't forget to change the sign for this value here. Now that we've learned all of these tools, the next step is to be able to graph our quadratic equation. So in order to graph it, what we need are the y-intercepts. This one should be quite straightforward. You just make x equal to 0. The x-intercept, where you make y equal to 0, and then you will need to solve for it. So there are 3 ways that you can find those x values. Firstly, you can factorize and use the null factor law. Secondly, you can complete the square and solve for x from there. And finally, you can use the quadratic formula in order to find x right away. You then need to find the turning point. Again, there are 3 different ways in order to find the turning point. So the first way is to be able to complete the square, and you'll find the h and k from there. The second thing you could do is average your 2 x values, which gives you the axis of symmetry, and then you can substitute that into your original equation to give you your y values. So that's average the x-intercepts. And finally, there is a formula that you can use where your x value, your axis of symmetry, is equal to negative b on 2a, and then you can substitute that in to, again, find your y value. So those are the 3 different ways that you can find the turning point. Make sure that if there is a restricted domain, that you also find the endpoints for that before you sketch that on. These 3 formulas here are just explaining different forms that your equation may be given in. So that's your turning point form. If the x-intercepts, this is the x-intercept form, or just the intercept form, this gives you your intercepts right away, and of course you just have your general form. So depending on what you have, these different techniques will be easiest, which is why you do need to know all of them, and you need to be able to apply them so that you can complete these questions as quickly as you can. So let's go ahead and apply some of these to our equations. So example 10 says sketch the graph of y equals 9 minus 2x plus 1 all squared, and there is a specific domain in this case, so negative 2 and 2. Once we sketch it, what it wants us to do is to state the domain and the range. So we're just going to follow those 3 things that we need to find. The first thing is our turning point, so that's pretty straightforward because it's just our h and k. There is a little bit of a trick to this one though. You have to make sure that if there is a value outside of the x, that you need to take it out. So there should never be a value in front of the x, only then can you see your true translation. So that'll be x plus 1/2 all squared. And then I can see that the translation of the graph, or the x value of the turning point, is in fact negative 1/2. And the 9 out the front indicates that that's going to be my y value of the turning point. In order to find the x-intercept, I'm going to make y equal to 0. Again, many different techniques to be able to find it, but since it's already in the form of the turning point form, I'm just going to solve for x. So I'm going to take this term to the other side to make it positive. And then I'm going to take the square root of both sides. That's going to give me plus minus 3. And then I'm going to take the 1 over, and then I will divide by 2. So that'll be negative 1 plus minus 3 on 2. If I work that out, negative 1 plus 3 is going to be 2 divided by 2 is 1, and then negative 1 minus 3 is negative 4 divided by 2 will be negative 2. So those are my 2 x-intercepts. And finally, I need to find my y-intercept, which is done by making x equal to 0. So y equals 9 minus 2 times 0 plus 1, all squared. 2 times 0 is 0, 1 squared is 1, 9 minus 1 is 8. I almost have all of my points to be able to sketch. The last thing I need to do is consider the domain. So this will only exist between negative 2 and 2, so I need to now find the endpoints. I'm going to complete that in this little corner. So when x is equal to negative 2, all I need to do is just substitute that in. So 2 times negative 2 is negative 4, plus 1 is negative 3, and that all squared is 9. 9 minus 9 is 0. we already know that x is also at -2 is an intercept, so that makes sense that it's 0. Then the other endpoint is that x is equal to 2, so 9 minus 2 times 2 plus 1 all squared. 2 times 2 is 4, plus 1 is 5. 5 squared is 25, and then 9 minus 25 is going to be -16. So that's my other endpoint. So now that I have all of my points, we're going to go ahead and sketch it. So what I can see is that my endpoint at -16 is quite low, so I'm going to sketch it to give me enough space. I have an x-intercept at 1 and at -2. I have a y-intercept at 8. So we might go up by 4, so that's 4, 8. And I also have my turning point at -0.5. So if this is -1, this would be -0.5, and at 9. I also know that my other endpoint, which is at 2, the y value of that is 16. So if we're going up by 4, so that's 4, 8, 12, -16. So that would be here. One thing you need to note is that this has round brackets, which means it's not included. So when I do draw those endpoints, they should in fact be an open circle to indicate that it's not included. So I'll just quickly fix up those axes. So that'll be 2 and -16. I'm just going to label all of my key points. Now I can go ahead and sketch the quadratic. This is our last example where we need to determine the equation of the graph and hence obtain the coordinates of the turning point. So they've already given me a diagram. They haven't given me any specific form that I need to put it in, so you can just use whichever form is easiest. In this case, I can see that I've got 2 intercepts, so I will use the intercept form to be able to find those. So that'll be a x minus b, x minus c, where b and c are both intercepts. And I also have another point that I can substitute in, which is 0 and -4. I know it's very close to the turning point, but you should never assume that this is the turning point unless it's been given quite clearly. So in this case, you can see that it's just off, so please don't assume that it is that turning point. Alright, I'm now going to go ahead and substitute in those y-intercepts. So the first one is -5. You need to make sure that you change the sign, so that'll be +5, and then at 8, so that'll be x minus 8. I'm now going to substitute in these values in order to find a. So when y is -4, x is 0. So that'll be 0 plus 5, 0 minus 8. That will be 5 times -8, which is -40. And then I'm going to go ahead and divide both sides by -40, which tells me that a is 1 on 10. So my equation will be 1 on 10, x plus 5, and x minus 8. Once again, if they give you a specific form, you need to make sure that you're able to expand that equation and then put it into the correct form that it wants you to. Now that's the first part of the question, the equation of the given graph. Find the equation, and then what it wants us to do is to obtain the coordinates of the turning point. Now I can go ahead and expand this and then try to complete the square, but that seems like a long process. Another way that we can find the turning point is by averaging out our 2 x-intercepts and then substituting that value into the equation in order to find y. So that's probably going to be the easiest way to do it. So we're going to do average the x-intercepts. I have -5 and 8. We know that it's going to be in the middle of those two, so 8 minus 5 is going to be 3, and then 3 on 2 is 1.5. So our x value is going to be 3 on 2. Now in order to find the y value, I'm going to substitute that in. I can imagine this is going to get pretty gross because it has some fractions. So let's see how we go. Alright, 3 on 2 plus 5, so 2 times 5 is 10, plus 3 is 13 on 2, and then 2 times 8 is -16, plus 3 is going to be -13, and that's on 2. So what we have is 13 times 13, so that's going to be -169, and then at the bottom, 10 times 2 is 20, times another 2 is 40. So my y value is going to be -169 on 40. So our final turning point is 3 on 2 and -169 on 40. And that there is the end of the examples for this. You can now complete exercise 4A and 4B with those questions.